Just briefly, completing example 9 from the last video, the direction vector from, or displacement vector from M to N. So starting at M, going to N, so the arrow's at N, means you have to go to left and up 3. So you can think of it as 2 left, negative 2i, and 3 up, plus 3j, to get the vector from M to N. Okay, that's the end of example 9. The next page, direction angles. The direction angles are just the angles from the positive x-axis. And notice the positive x-axis, and it's drawn 3D. Positive x is coming out of the page towards you. Y is going to the right, and Z is going straight up. So in the classroom, I would point out the corner of the classroom, and I would walk through the whole thing, but here we go. You have to visualize it. Alpha, okay, is from the positive x-axis to the vector. Beta is from the positive y-axis to the vector. And gamma is from the positive z-axis to the vector. Direction angles. Scalar components, x, y, and z components. The components that would be on the x-axis and the y-axis and the z-axis are v sub x, v sub y, and v sub z. And in component form, you have an ordered triple, if you like, giving the 3 components. Link between the direction angles and the 3D scalars. Well, it's the cosine of the direction angle. So alpha is the angle between the x-axis and the vector. So the magnitude of the vector times the cosine of alpha gives you the x component. Similarly for the y and angle beta, and the z and angle gamma. So here are the formulas. This is 3D Pythagorean. Sorry, 3D, not 3P. Pythagorean. And we just have the cosine of an angle. These are the direction cosines. That's what they're called. It's called the direction cosines. And we have this Pythagorean identity. It's very much similar to this one that you should be familiar with from grade 11. Very similar and analogous to that, but this time for 3 dimensions. All right, example 10. We have magnitude of 20, and we have the 3 direction angles, 60, 45, and 60. Write the vector A in algebraic form using the scalar components. So A sub x is equal to the magnitude of A cos alpha. So 20 times the cos of 60, which is 10. AY is A cos beta. 20 times the cos of 45, and that's 10 root 2. A sub z, the z component, magnitude of A, cos of gamma, 20 cos 60, which is again 10. So in component form, we have 10, 10 root 2, and 10. Standard unit vector form, which we haven't talked about standard unit vectors yet. This would be 10i plus 10 root 2j plus 10k. That's in standard unit vector form. Example 11, find the direction angles for the vector. Well, the magnitude of u would be 2 squared plus 3 squared plus negative 1 squared, which is the root of 4 plus 9 plus 1, root 14. And we're running out of time. I'll do one more component, and then I'll come back on the next one. So, sorry, we're doing angles. Cos of alpha, u sub x over the magnitude of u, negative 2 over root of 14. So alpha would be equal to 122.31 degrees.